Alright, let's dive into the problem we have at hand. We're looking at proving the equality between two functions involving folding operations. The goal is to show that for all finite lists, the left-hand side equals the right-hand side. We have some provisos to consider, which add an extra layer of complexity to the proof. Now, entering into the solution provided, we start by focusing on a specific relation denoted as A, involving the folding operation. The equation states a relationship between the concatenation of elements within the folding process. This intermediate step sets the stage for the subsequent parts of the proof. Moving forward, we dissect the process step by step, beginning with the base case for the intermediate result. By applying the definitions of foldal and the properties given, we can see how the concatenation of elements unfolds within the folding operation, paving the way for a deeper understanding of the intricacies involved. Expanding further on the solution, we delve into the inductive case for result A. By recursively examining the concatenation of elements within the folding operation, we establish a pattern that showcases how this relationship holds true as we progress through the list, reinforcing the validity of the initial proposition. Proceeding with the proof, we now shift our focus towards proving the desired final result denoted as B. By leveraging the intermediate result, A, and building upon the properties provided, we construct a solid foundation for showcasing the equivalence between the left and right-hand sides of the functions involving foldal and folder. Continuing with the explanation, we move on to dissecting the base case of result B. By tracing through the folding operations with an empty list, we unravel the transformations that occur and how they lead to the expected outcome, highlighting the importance of understanding each step in the process. Now, progressing to the inductive step for result B, we unravel the complexities involved when an element is added to the list. By following the sequence of operations and applying the given properties judiciously, we arrive at a point where the equivalence between the two sides becomes clear, solidifying the proof. In summary, through a meticulous breakdown of the folding operations and by leveraging the provided properties, we've successfully proven the equality between the two functions for all finite lists. With this, we wrap up our discussion. Remember to like, subscribe, and leave a comment below. Who knew folding could be this exciting, right? Thanks for watching.